Hello everyone. In today's video, we will talk about the link state routing. Link state routing is one of the important routing protocols in the networks, which works on the principle of shortest path first. And the actual protocol which implements the concept of link state routing is known as OSPF, which stands for Open Shortest Path First. So, for implementing OSPF, first of all, we require 3 routers. So I'm taking 2 routers here. Let's take one more router. And I require a switch to connect the PCs. So let's take 2 routers here. Sorry, switches here. Then I'll require a N device, which has to be connected to each and every switch. I've taken one device here, and let's take another one here. Now let's make the connections in all the devices. First of all, connect PC with that of a switch, then connect the switches further to the routers, then make the connection between the switch with the another switch. And you can see that when I'm connecting the serial ports, the serial port, the wire is showing as the serial wire. So with this, we have created the necessary connections. However, you can see all the lights are still red. It means there is no connection which is working fine to send the data from one station to another station. So for doing the OSPF, first of all, we need to complete the basic IP address configuration on all the devices. For that, let's start from the PC0. PC0 is connected with switch 0, which is further connected with that of your router 0. So router interface F is 0 by 0, switch and PC0, they are part of the same network. I'll be considering this network as part of 10.0.0.0 network. Similarly, on the right hand side, the second PC is connected with switch, and the switch is further connected with the serial port here. Now, there is one important thing that you all must understand, that we must be aware that which particular port is connecting us to which device. I have seen my own students doing this silly mistake where they are doing the wrong IP address settings for the wrong ports. For example, in case you are not sure that what is the label of this port, then we do have one option available in the Cisco Packet Tracer where you can go to the options. There is first option of preferences. Just click on it and there is one option of always show port label. See, if I uncheck it, all the labels has gone away. They're hidden now. However, for the better understanding, I'll keep them always on. So I suggest you to always keep them on so that you can see which port is connected to which particular label and which port number. All right, without wasting much time, now let's start doing the configuration for the PCs. This left-hand side PC0 has to be given the IP address from the range of 10 series. So I'm giving the IP address 10.10.10.2 to this PC. Subnet mask, as you know, will always appear by itself. Then default gateway. The default gateway for this PC will be the router interface, that is F is 0 by 0 for router 0. And I'm giving this the IP address as 10.10.10.1. Cross it and this IP will be saved. Now I'll go to this router interface and you can see that this router interface router 0 is connected to the PC 0 with F is 0 by 0. So I'll open the interface and you have to assign the IP address to the F is 0 by 0 interface. First of all, make sure that the port status is on and then you assign the IP address to the router interface, which has to be 10.10.10.1, which is equivalent to the gateway address and then the subnet mask. With this, we are done with the IP address setting for this side, and you can see that the light has turned green. So it means the connection has been established between switch and that of the router. As of now, we are done with just one connection, And you can very well see this router 0 has got multiple interfaces. This one is to serial port 2 by 0. This one is serial 3 by 0. So next setting that I am going to do is for the second PC. I'm leaving all these serial ports as of now so that we can understand the OSPF routing in a better way. Now I'll go to PC1. Now this PC1 is connected with this second switch and this one is connected with the router 1. So this entire side I am considering as network number 20.0.0.0. So let's start assigning the IP addresses to PC1 here. The PC1, go to the desktop, IP configuration. Let's assign the IP as 20.20.20.2. Similarly, subnet mask, then default gateway. I'm copying from here to save a little bit of time for me. Oops. And then .1. And this default gateway is the IP address of the router interface, which is connecting me to this switch. So which is F is 0 by 0 again. So I'll open up this second router, go here, go to the config, go to 0 by 0, assign the IP which I have just copied, which was 20.20.20.1, and then I will click on the subnet mask, port status on, close it. Now I'm done with the settings for this side of router. Along with that, I'm done with the settings for the second side of router. For more clarity, because there are the labels are overlapping each other, I'm changing the topology a little bit. And this side it is F is 0 by 0. Now I'm done with this side of setting and this side of IP addressing. Now let's go to the second side, that is between serial port 2 by 0 with that of serial port 2 by 0. Now on this router 0, you can see that serial port 2 by 0 has got a clock also. This clock means that we need to assign the clock rate for this router also. So I will be assigning this network as the IPs from the range of 30.0.0.0. So click on this router. Let's go to the serial port 2 by 0 now. Port status on. Then make sure that you are assigning the clock rate because the clock has to be set here. Then let's assign the IP from the range 30. 30.30.30.1. Did I say 34 times? So I have to just write 30.30.30.1 and subnet mask will come by itself. And with that, I am done with the serial port 2 by 0 interface configuration. So I'll just close it. Now this serial port 2 by 0 is connected with the serial port 2 by 0 of router 1. And it means serial port 2 by 0 also has to be assigned some IP from the same range. And you can very well see serial port 2 by 0 in router 1 does not have any clock along with that. So we need not to set any clock rate. So I'll go to serial port 2 by 0, assign it the IP address, which is 30.30.30.3. You can take it as 3. I guess I took the previous one as 2, so I'll take this as 3 and on, and make sure the clock rate is set on, not set. So with this, we are done with the configuration of serial 2 by 0, and here it is 30.30.30.2. Sorry, 3. This is 3, and serial port 2 by 0 here is .1. It is 1. So we are done with the setting for this side. Now let's do the configuration for router 0 and interface serial 3 by 0. This side network, I'm repeating it again. This is 10. This one I have taken as 20. And this central one is as 30. So let's take this one as in IP address from the range of 40. So 3 by 0 serial interface. 3 by 0 is here. And there is one clock rate also here. So port status on, clock rate 64,000. IP address, let's take it 40.40.40.1. Default gateway is there. Cross it. And we are done with serial port 3x0 setting for router 0. Similarly, now let's go to router 2 and serial 3x0 here, and there is no clock rate which we have to set. So go here, config serial 3x0, port status on 40.40.40.2. Subnet mask cross it. So this has also turned green now. Now we are just left with this side of setting. This is 10. I'm saying it again so that you are not doing anything incorrectly. 10. This one is 20. This upper one is 30. This one is 40. And the last one is 50. So serial 2x0 has to be set to some IP address from the range of 50. It is 2x0. Let's go to 2x0. Port status on 50.50.50.1. Subnet mask, cross it. Similarly, let's go to 3x0 of router 1. Router 1, serial 3x0, which is here. And you can see the clock is here. You have to set the clock rate on 64,000. And the IP is 50.50.50.2. Subnet mask is set and done. With this, we are done with the basic settings. But if I show you that, will I be able to send the data from PC0 to PC1, then it will show me failed. The reason for that is, till now, my PC is only aware that how do it will send the data to this router. So if I'll try sending the data from my PC to router 0, you will see that it will show you successful because I have given the settings for the default gateway in the PC IP address setting. Similarly, I'll be able to send the data from PC1 to router 1. It will be successful. However, when I'm sending the data across the different networks, then it will be showing as failed. The only reason for that is because till now we have not done any type of routing. So for this topology, let's do the link state routing with the help of OSPF. For that, what you have to do is you need to go to each and every router and you have to publish each and every network which is directly connected with this router. For that, I need to go to the CLI. CLI stands for command line interface. In the command line interface, you just press once. It will show you config if. Config if is because we were doing the configuration for the interfaces. So we need to exit this. Once you exit it, it will show you config. On the config, we have to do the OSPF setting. For that, the command is router OSPF number 1. Then press enter. After that, you have to publish all the networks which are connected with this router. So the first network with which this router is connected is 10.0.0.0. We are writing 0.0.0 as there can be any device of this type. It can be 10.10.10.1, it can be 10.10.10.2 or any value. After that, we are done with the IP address of the network. Then we have to mention the subnet mask, but we will not be writing the subnet mask directly. We need to write the complement of that subnet mask. The subnet mask for class A is 255.0.0.0. So the complement of that will be exactly opposite of that, which will be 0.255.255.255. And then you have to mention the area. Let's take it as area 0 and press enter. So with this, we have published just one network. Similarly, you know that this router 0 is also connected with other networks also, that is 30 and 40. So for doing it, you need not to type the entire command. You can just press the up button, up key on your keyboard, and it will show you the previous command. So here you can modify the settings. On the router, the second network with which it is connected is 30.0.0.0. And then you will write the complement of your subnet mask. that is 0.255.255.255 and then area 0. Press enter. And the third network with which this router is connected is 40.0.0.0. And then you have to write the complement of subnet mask and mention the area as 0. And with this, we are done with the routing with the help of OSPF on one of the routers. Then type exit. You can type exit again, and it is saying that configured from console by console. So it means we have done the settings on the console of the router. Now, similarly, I will go to the router 2 and publish all the networks with which my router 2 is connected. This is the same CLI interface. Press exit, type exit, sorry. Then let's write the same command, router OSPF 1. Press enter. Then you have to publish the network. So the network with which your second router is connected is 40.0.0.0. Then complement of subnet mask. And then you have to write area 0. That is my first network with which this router is connected. You can see that the router 2 is connected only with 2 networks, right? The second one that we have to do is .40 and the second one is with the IP 50.0.0.0.0 and then complement of your subnet mask. Press enter, then press exit, press right exit, and we are done with the settings for the second router. Now we are just left with the third router. Again, same commands. Go here, exit, write a router OSPF 1, and then again. Now this network, with this router, there are 3 networks connected. So network, it is 30.0.0.0. Again, the complement of subnet. Then mention the area 0. Let's label it as area 0. Press enter. And then again, same setting. The second network with which this is connected is 20, which is towards the PC 1 side. Press enter. We're done. And the third network with which it is connected is 50, which is this side network. All right. 50.0.0.0.0, and then you have got again the complement and mention the area. Press enter, exit, exit. And with this, we are done with the OSPF setting. But till now, we are not sure whether the network is working fine or not. So for that, let's cross verify now. And let me tell you, in case for the first time, it fails for you, don't worry, because your routers will take a little while to share the routing information with one another. However, for my case, it was successful in the first go, but it is all right. If it has failed for you for the first time, then you can go to the simulation mode and then you can see the auto capture, then press on auto capture play and you will see that after the first go, your routing will start working perfectly and your routers will be forwarding the data to the adjacent networks without any problem. So you can see that the data is now moving from the switch towards the PC. And then this PC will be sending a reply back, which you may also call as the acknowledgement to the sender device again. Now it is there with the switch. Then we'll go to the router, and via router, it will again go to the second device. And then again, it will be there with the switch, and then it is there with PC 0. and you will see the status has changed to successful. Now, let me tell you something interesting here. Now, you can see that there are multiple routes available for this PC to send the data to PC1. However, PC0 have chosen a direct link because it was the shortest path between PC0 to PC1. So now what will happen if I remove the link, the direct link which is there between the device router 0 and router 1? Do you think the data will not be forwarded? I hope by now you are all clear that if the direct links are not available between the routers, then your router will take the alternative path. Now let's see whether it is working fine now or not. So the data is there with the router 0. Now the router 2 has taken the alternative path where it is following a longer route because there was no other way out available with the router to forward the data. So it's there with the PC1. From sender to receiver, the data is received by the receiver. Now the receiver is sending the reply back to the sender. And then after that, I'll show you something interesting again. So the data is going fine till now. So it's there with the router 0 now. Router 0 will forward that data back to the switch. Switch will send that data back to PC 0. And yes, we are done with the successful delivery of the message between PC 0 to PC 1. Now, what if I bring the connection again between router 0 to router 1? I need not to do all the settings again because the settings are already saved in the interfaces. It is just the wire that I have connected again. Now, I have made a connection again between two devices, not devices, actually the routers. Now let's see whether this router is forwarding the data via this link or via previous link when this link was down. Let's check it out. PC0 is the source, PC1 is the destination. And now let's see the simulation mode. It has shown me the successful. See, it has shown me the successful, but till now I'm not sure which path my router has chosen. So let's do the simulation and check out which way is chosen by my router. So it's there. I have just increased the speed. Now see, when the link was down, the data was going via this link. But again, when the link is again up, my router has started sending the data via the shortest path again. Isn't it amazing that how your network is changing the paths as per the availability of the paths? So this is how your link state routing work, which will always choose the shortest path available between two networks. And whenever the shortest path goes down, in that case, it will choose the next alternative path. I hope this video has made the link state routing protocol implementation easier for you to understand. And if you like the video, do comment with your doubts or whatever you understood or whatsoever you did not understand. I'll be happy, more than happy to answer your queries. Thank you so much for your time. Take care. Have a good day.